Welcome to Mythosium, the channel where we take big scientific ideas and make them intuitive enough to feel like common sense. Today we're diving deep into one of the most powerful and surprising concepts in all of game theory. A concept that reshapes how you understand conflict, cooperation, trust, betrayal, negotiation, and even the structure of societies. This single model has influenced economics, biology, psychology, computer science, and the study of human behavior. And once you understand it, you begin to see its patterns everywhere, in workplaces, friendships, families, online interactions, ecological systems, and even inside evolutionary processes that long predate human civilization. At the center of this idea is a deceptively simple structure, the prisoner's dilemma. It is one of those things that seems small at first, almost too simple to matter. 2 players, 2 choices each, and a few payoff values. Yet this tiny framework creates a tension that mirrors the deepest challenges faced by any organism or group trying to coexist with others. It counters why cooperation is difficult, why conflict is tempting, and why systems of trust take so long to build, and only moments to destroy. The classic version of the dilemma works like this. 2 individuals each choose between cooperating or defecting. Cooperation benefits both, but not as much as defecting benefits the defector when the other cooperates. And mutual defection is worse for both than mutual cooperation. Of the key is that defection always looks more attractive no matter what the other player does. It is the dominant strategy. But when both choose it, they both lose. Compared to what they would have achieved through cooperation, the logic of selfish action leads to a worse collective outcome. This is the paradox. Rational behavior leads to irrational results. And this isn't just a quirky mathematical artifact, it reflects something profound about how incentives shape real-world outcomes. Cooperation often requires taking a risk, trusting that the other party isn't going to take advantage of you. Defection promises a short-term reward, and cooperation requires believing that the long-term benefits of mutual trust outweigh the temptation of exploiting someone who is being kind or generous. But life isn't lived in single moments. People, groups, companies, animals, and even entire species interact repeatedly. The same individuals meet again and again, forming patterns, routines, habits, and expectations. And when interactions are repeated, everything changes. Suddenly, the game is no longer about maximizing a single payoff, but about shaping a relationship over time. The future becomes part of the present decision. Tomorrow's behavior depends on today's choices. Small actions echo across repeated interactions, creating stable or unstable cycles of cooperation. In a repeated setting, cooperation becomes possible, even rational. But how it emerges, how it stabilizes, and how it collapses requires careful thought. The simplest repeated strategy, always cooperate, is unstable because the temptation to exploit it is too great. Always defect is stable, but yields low payoffs. So the real challenge is to find strategies that encourage cooperation while protecting themselves from exploitation. This is where strategic design becomes fascinating. A strategy must balance generosity and caution. It must encourage partnership, but discourage cheating. It must respond proportionally to betrayal without locking itself into endless cycles of retaliation. And ideally, it must be simple enough that its behavior is predictable. The ideal strategy must be transparent in a way that other players can understand and adjust to. This is why simple strategies often outperform complicated ones. A strategy that is too clever or unpredictable confuses its partners. If a partner cannot anticipate what you will do, they cannot coordinate with you. Cooperation requires clarity. Researchers exploring these dynamics famously ran tournaments where different strategies competed across hundreds of repeated games. Some strategies tried to be calculating, storing long histories of interactions. Others were purely reactive, responding only to the last move. And others attempted to manipulate or deceive, planning to defect at key moments. But the winner was not a complex or deceptive strategy. It was tit for tat. A strategy so simple that it could be described in one sentence. Start by cooperating, then do whatever the opponent did in the previous round. This strategy embodies friendliness, retaliation, forgiveness, and clarity. It extends a hand first. It punishes betrayal immediately. It forgives one misstep instantly if the opponent returns to cooperation. And it is so predictable that others quickly understand how to interact with it. Tit for tat creates a stable environment where cooperation is rewarded and defection is punished, but not forever. This balance is critical. Permanent punishment is too harsh. Permanent cooperation is too naive. Tit for tat sits in the sweet spot. Once this strategy proved successful, people began exploring why it works and how robust it really is. They found that it thrives in environments where players interact frequently and anonymously. It works in competitive and mixed populations. It even works when opponents use highly complex strategies, but its biggest weakness appears when noise enters the game, when actions are misinterpreted or mistakes occur. For example, a strategy may intend to cooperate, but a signal gets flipped or a misreading occurs. Suddenly, tit for tat sees a defection and retaliates. The opponent sees the retaliation and continues the cycle. Cooperation collapses through no one's intention. This is where generosity becomes essential. Strategies that mimic tit for tat but occasionally overlook a defection or give the other player a second chance perform better in noisy environments. They maintain deterrence while preventing accidental spirals of hostility. A touch of grease stabilizes cooperation. Generosity prevents chaos. This idea extends beyond game theory and into the real world. Think about relationships between people. One mistake can escalate into a chain of misunderstandings if both sides respond immediately and harshly. Forgiveness allows systems to return to cooperative states. Too much retaliation tears them apart. Too much leniency invites exploitation. The principles discovered in simple computer tournaments reveal something deep about the structure of peaceful coexistence. Another layer of the prisoner's dilemma becomes visible when we think about evolution. In biological systems, strategies are not consciously chosen. They emerge from natural selection. Organisms that adopt effective patterns, whether through instinct or behavior, outcompete those that do not. In many species, cooperation is beneficial in the long run because it increases survival, reproductive success, and protection against common threats. But cooperation always carries the risk of being exploited by defectors. In some species, cooperation emerges through kin selection. Organisms help relatives because they share genes. In others, cooperative behaviors appear in individuals who interact repeatedly over a lifetime. But the prisoner's dilemma shows that cooperation can also emerge without genetic ties or conscious intention. All it requires is repeated interactions where reciprocation is possible. Nature has discovered these principles countless times. Species that groom each other, protect one another, hunt together, or share resources are unknowingly playing repeated games shaped by these same dynamics. The elegance of the prisoner's dilemma lies in its generality. The same structure appears in environmental problems, workplace dynamics, online interactions, and the formation of large social networks. Whenever individuals face a choice between doing what is best for themselves in the short term or doing what is best for the group in the long term, the logic of the dilemma appears. This is why the model has been used to analyze everything from public goods to social norms to behavior on digital platforms. One of the most interesting extensions arises when you consider not just two players, but entire populations interacting in networks. In a large group, individuals may not meet the same partner repeatedly at predictable intervals. Instead, they encounter different partners at random, forming a complex web of interactions. In such cases, cooperative strategies depend on clusters. If a small group of cooperators interact mostly with one another, they can outcompete defectors and gradually expand. But if cooperators are scattered randomly, defectors may eliminate them before they can gain a foothold. This reveals another profound insight. Cooperation often emerges from structure. When networks form stable clusters, families, communities, alliances, cooperation becomes easier to sustain. When networks are fragmented or constantly reshuffled, cooperation may collapse. Order and stability create conditions where trust can grow. Chaos undermines it. This matches what we see in real societies, where trust tends to flourish in stable communities with repeated interactions but falters in systems where interactions are anonymous, unpredictable, or transient. Another extension of the dilemma involves signaling. In many real-world situations, individuals can send signals about their intentions. Sometimes these signals are costly, meaning that they cannot easily be faked. Costly signals allow cooperators to recognize each other and avoid defectors. This leads to assortative matching, where like interacts with like. Cooperators cluster together, forming high payoff groups that outperform defectors. But if signaling is cheap or deceptive strategies evolve, cooperators become vulnerable again. This dance between signaling, deception, and verification plays out constantly in ecological, social, and economic systems. When you consider long-term evolution, another surprising pattern emerges. Strategies that punish defectors harshly but reward cooperators generously often rise to dominance. These strategies balance compassion with deterrence. They allow stable cooperation while preventing exploitation over time. They outperform strategies that are too harsh or too forgiving. The balance point shifts depending on the environment. But the general principle remains: successful cooperation depends on the ability to detect affection, respond appropriately, and restore cooperation when possible. As we push deeper into the conceptual landscape, we find that the prisoner's dilemma forces us to confront questions about rationality itself. The assumption that rational actors will always defect leads to a suboptimal outcome, yet mutual cooperation is better for both players. This reveals that rationality based solely on immediate payoff is insufficient in repeated or social contexts. True rationality must account for the long-term structure of interactions. It must consider future consequences, reputational effects, and the possibility of constructing stable expectations. This realization reshapes how we think about incentives. Systems that reward only short-term gains tend to collapse into defection. Systems that reward long-term cooperation tend to flourish. This principle guides everything from workplace culture to governance systems to scientific collaboration. Cooperation is fragile unless institutions or norms reinforce it. But when norms and incentives align, cooperation becomes incredibly resilient. Another dimension worth exploring is the emotional component. While the prisoner's dilemma is formulated mathematically, real behavior is influenced by emotions. People often cooperate out of empathy, guilt, pride, or a desire for fairness. These emotional responses can stabilize cooperation even when logic alone suggests defection. In evolutionary terms, emotions may serve as heuristics that encode successful long-term strategies, even though the math does not include emotions. Emotions may reflect the solutions that evolution discovered in repeated social interactions. This brings us to the final layer. The world looks different once you see it through the lens of the prisoner's dilemma. Everyday conflicts take on new meaning. Many disputes arise because individuals prioritize short-term gain over long-term benefit. Many cycles of hostility emerge from misunderstandings. Many broken systems collapse because incentives reward defection. And many successful relationships, personal or professional, thrive because both parties repeatedly choose cooperation and occasionally choose forgiveness. The power of the prisoner's dilemma is that it reveals why cooperation is possible, why it is hard, why it collapses, and how it can be restored. It shows that cooperation is not naive, it is strategic. It is not fragile when supported by the right structures. It can emerge in competitive environments. It can evolve naturally. And it can stabilize entire communities, species, or networks. At Mythosium, we explore ideas like this because they illuminate the deep patterns that shape our world. Understanding them helps us understand ourselves, our societies, and the systems we participate in every day. If you enjoy learning how simple mathematical models can reveal complex truths about the world, make sure to subscribe. We explore big ideas with clarity and curiosity, one episode at a time. Thanks for watching, and stay curious.